In CP3-5, you will be able to apply the formula for circumference of a circle in real-world application problems, and you'll be able to use dimensional analysis to solve problems and convert between units. Let's start with a first example. Usain Bolt ran 100 meters in 9.63 seconds. Find his speed in miles per hour. So this is a dimensional analysis problem, and we're trying to change our units. So I like to always start with what I'm given, which is 100 meters in 9.63 seconds. And what I like to do when I solve these problems is I like to convert the numerator first, but it doesn't really matter which one you choose to do first. So what I'm going to do here is I'm going to actually multiply this by 1, because when we multiply by 1, we don't change anything about it. And when I multiply it by 1, I want to make sure that meters is in the denominator because I want meters and meters to cancel out. And as I look here in the bottom, it tells me that 1 meter is about 3.28 feet. 1 meter is equal to 3.28 feet. So I can say that 1 meter is the same thing as 3.28 feet. Now let's just pause and think about this for a second, because as I said before, this entire thing has to be equal to 1. And since 3.28 feet is the same thing as exactly 1 meter, this is equal to 1. And the cool thing about this is because our meters cancel out, we're going to be left with an answer that has feet. Now, our problem didn't want our answer in terms of feet. It wants it in terms of miles. So we need to do another multiplication by 1. And I am told that 5,280 feet is equal to 1 mile. So as I'm looking at what my next fraction is going to look like, I want feet in the denominator so that feet and feet will cancel. So when I put this information in, it tells me that 5,280 feet are equal to 1 mile. Again, this fraction has to be equal to 1. 1 is equal to 5,280 feet, so it is 1. Now, as I look at all my numerators, the labels cancel out except for miles. I'm left with miles, and in my problem, it asks the final answer to be in miles. So I am done with the numerator. It does say that it wants it per hour, and as I look at my denominator, it is currently in seconds. So I now need to work on changing seconds to hours. All right, so we're going to again multiply by 1. The numerator and denominator have to equal 1. I am now trying to cancel out seconds because we had seconds down here, so I want seconds in my numerator so that these can cancel. So I'm going to change my seconds into minutes, and then our last step will be changing minutes into hours. So we know that in 1 minute there are 60 seconds. We have one more to do because now we have minutes, but we want to change minutes to hours. I know that my minutes have to be in the numerator because I want minutes to cancel, and I want to be left with hours. There are 60 minutes in 1 hour. As we look at this problem now, I can see that I am left with miles per hour. All of the other units have canceled. We now have it in terms of the labels that we want. So at this point, we're ready to do some multiplication. At this point, we can now multiply all the numbers on the numerator, multiply all the numbers in the denominator. We will get it in miles and hours, and then we're going to need to simplify by dividing to get it to be miles per 1 hour. So go ahead and multiply the top numbers, multiply the numbers in the bottom, and make sure yours looks like mine. So you should have gotten this answer. Now we want it to be per 1 hour. So what we're going to do is we're going to take those numbers and just divide them. And we get about 23.2 miles per 1 hour. Let's take a look at another one. Clementine can walk 6 inches in 15 seconds. Find her speed in miles per hour. So again, let's start with what we're given, 6 inches in 15 seconds. Again, I like to start by changing the numerator. So I'm going to change the inches into miles. Okay, and then we'll get to the seconds to hours. So when we go to change it, remember we need to multiply by 1. And I want my denominator to be inches. I know that there are 12 inches in 1 foot. My inches cancel. Now I'm going to change feet, knowing that at the bottom it tells me there's 5,280 feet in 1 mile. I know feet needs to be in the denominator because I want my feet to cancel. So I'm going to do 5,280 feet in 1 mile. As I look, mile is how I want my answer. So I have now changed inches to miles. We're going to move on to seconds. I'm going to change seconds. So remember, seconds currently is in the denominator, so I'm going to put it in the numerator. I know there are 60 seconds in 1 minute. My seconds will cancel. Then I'm going to change my minutes, so minutes has to go in the numerator, to hours. 1 minute. There are 60 minutes in 1 hour. Again, remember all of the fractions that we're multiplying have to be the same thing as 1. At this point, we have canceled everything, and our labels will be left in miles per hour, which is good because that's what our question asked for. We're going to multiply all the numbers in the numerator, multiply all the numbers in the denominator.
Checkpoint problems and attention on the tests that you might have that. And she is going 0.0.
Let's recall our circumference formula. Remember, it's the distance around the circle, and we learned this year it's either 2 pi r or pi times d. Those are the same, where r is the radius and d is the diameter. We're going to use and apply this. All right, let's look at our first example of this. The wheel on Susie Cream Cheese's unicycle has a diameter of 27 inches. How far will the unicycle travel in 100 revolutions? Round to the nearest whole foot. Notice how it says round. Okay, this is going to be when you're going to use the pi key on your calculator. Use that pi button. Okay, I know before I told you not to. Now you're going to do it because it does say to round. So in this one, it wants to know how far if we're going around 100 times, which means we need to look at their circumference. Let's remember that circumference is equal to pi times diameter. So 27 pi. And many of you right now would be tempted to type this into your calculator and to use the pi key, but you would actually be rounding early. And what that means is that every step, every time you multiply, every time you do another part of this equation, you're rounding even more, which makes your answer further and further from the correct answer. So we're going to wait till the very, very end to round our answer. Now, this is just one time around. It's telling us that she's going 100 times around. So the distance is equal to 100 times 1 time around, 27 pi. Now you can go ahead and type this in your calculator, and you can use the pi key, and you will get 8,482, rounded to the nearest whole inch here because 27 was in inches. But if I go back up to my problem, it wants our answer in terms of feet. Good news is we learned how to use and apply dimensional analysis in the previous examples. We're going to change inches now to feet. We're going to multiply. Remember, we need to multiply by 1. I need inches to be in the denominator because then my inches will cancel. And I know that there are 12 inches in 1 foot. So what we're going to do now, since I want my answer in feet, we don't have to do any more multiplying. we're going to take 8,482, multiply it by 1. Multiply the numerators. Be feet per 12. And we need to now divide to get a final answer of 706.83 repeating feet. It does say to round to the nearest whole foot, so this would be 707 feet. Another example, the wheel on Susie Creamcheese's bicycle has a diameter of 27 inches. Susie rides her unicycle 2 miles to school each day. About how many revolutions does the wheel make during each trip? So the distance is going to equal the revolutions times the circumference. Now, I see here we're looking at inches and miles. We have to have them in the same form. So I'm going to choose to change miles into inches because I don't want to deal with teeny tiny numbers. I'd rather deal with large numbers. So we're going to take 2 miles and I want to change it into inches. So I know that miles needs to be in the denominator. And I practiced before that 5,280 feet are in 1 mile. Miles will cancel. I'm going to multiply again because I don't want it left in feet. I want it left in inches. I'm going to put feet in the denominator. That way feet and feet will cancel. I know that there are 12 inches in 1 foot. Since we are now left with just inches, we can go ahead and multiply our numerators to get 126,720 inches. And 1 times 1 is 1, so this is our final answer. 126,720 inches is how far she has to travel every day. Now, I'm going to go back and look at the formula that we wrote, and I know that this number is my distance. So 126,720 is the distance. We don't know the revolution, so I'll just call it R, and then times our circumference. Remember, circumference equals pi times d. So diameter is 27, so 27 pi. And now we're going to divide both sides by 27 pi. Remember, do not do 27, use the pi key, 27 times pi until the very end. We're going to do 126,720 divided by 27 pi. Now be very careful when you do 27 pi that you put it into parentheses, or you do 27 times pi, enter, and then 126,720 divided by that answer. So be very, very careful. Try it to make sure you're doing it correctly, and you should get 1,494 revolutions. All right, Billy Bagel is driving a remote control car in a circle with a radius of 5 meters. He clocks the car at 10 seconds per revolution. What is the speed of the car in meters per second? So the circumference is 2 pi r. So 2 times 5 is 10, so we have 10 pi. Now, our problem says that he's clocking the car at 10 seconds per revolution. So for every revolution, for every 10 pi meters, it takes 10 seconds. Now, it's asking what is the speed of the car in meters per second. So in meters per 1 second. As I look at this, I can reason through. I can divide 10 and 10 to get just pi meters per second. In the real world, I'd probably call that 3.14 meters per second. Another way to look at this problem is to remember that distance is equal to rate times time. So if we know that our distance is 10 pi, we don't know our rate, so we'll just call that r. We know that the time is 10 seconds. So now I can just solve for r. by dividing both sides by 10. And I get pi is equal to the rate, which means it's pi meters per second. Notice our answers are the same. Patty Peanut Butter opens up a pizza place. She sells 7-inch pizza for $12, an 8.5-inch pizza for $14.50, and a 10-inch pizza for $16. Measurements are of the radius of the pizza. What size has the most crust per dollar? So we're going to look at each of these. We have 7 inches for $12. We have 8.5 inches for $12. And we have 10 inches for $16. Okay, now this is the radius, 7 is the radius. So what we're going to do when we look at this, we want to figure out how much crust per dollar. So crust would be the distance around. Circumference, pi times diameter, 2 pi r. So 7 times 2 is 14 pi for $12. And I want it to be per $1. So to find that unit price, we're going to divide by 12 to get it down to that $1. So 14 pi divided by 12 gives us a unit price of $3.67, or not dollars, that's 3.67 inches per $1. All right, let's take a look at the next one. So we're going to do circumference. 8.5 times 2 is 17 pi, and it's not actually per $12. It is $14.50. So over $14.50, and I want it to be per $1 so we can compare. So I'm going to divide by $14.50. So 17 pi divided by $14.50, I get about 3.68 inches. And then our last one we're going to look at, circumference. 10 times 2 is 20, so 20 pi over 16. I again want it to be per $1 so we can compare. So to get it down to 1, I'm going to divide by 16. 20 pi divided by 16 is 3.93 inches for that dollar. So now let's look back at them and let's compare. I could either get 3.67 inches for a dollar, 3.68, or 3.93. I'm going to go with 3.93 because I'm getting almost 4 inches for that $1. That one, if I care about the crust, is giving me the most crust per dollar spent.